Scientific Communication, presented by VMG Academy, New Delhi, India. Lecture by E.R. Mandeep Singh. Scientific Communication. Now, let us understand some of the salient features of the program. This module has been divided into 4 sections. First, science education. Second, scientific skills. Third, elements of scientific communication. And fourth, industry and business related to science. Lecture 1. Science Education. Let us begin by understanding the meaning of the word science. Science, as pronounced in English language, means knowledge, skill, a technique, or a belief. This word science is probably derived from an old French word, scion, which probably descended from a Latin word, scientia, and all of them means the same thing, knowledge or skill. Now, we shall try to understand what science education is and the scientific philosophy or the working principles that lay the foundation to the science education. Science education, it deals with the natural phenomenon, nature like plants and animals. It tells us about the nature of matter and substances, what they are composed of, their behavior, and so on. It gives us knowledge about man and the physical world. It is a study of tools, tooling method, and techniques which can be applied in our daily lives. And some of the applications associated with science education, which deals with creation of arts, crafts, and designs. So, what are the scientific principles? It is a philosophy that governs science education. Scientific principles can be divided into 5 basic objects. Now, these are not objects. It is a specialization in itself. It is a doctrine. It is a method or a tool. The way science education is imparted. One receives science education only through these objects. So what are these? Let us try and understand. First is the observation. It deals with inspection, surveillance, carrying out survey, or conducting an examination on any object or any material thing. Second, hypothesis. Hypothesis is a way of making statements, making some assumptions, building some axioms and postulates. And if a hypothesis or your statements are true, it leads to establishment of a theory. And in case of science education, we may call it a scientific theory. Experimentation. Experimentation is one of the most important process in one of the most important scientific principles that deals with carrying out investigation and testing or conducting some trials. Fourth, analysis. After having done observation, making some statements and carrying out experimentation, to understand the results is of prime importance. So, analysis deals with interpretation of results, interpretation of the results of the experiments and the observations. And the fifth one is applications related to science. It is an approach to make some tools, new technology, and of course, scientific applications lead to discoveries and inventions. Next, we try and understand what science education is composed of. Science education can be broadly divided into 3 different components or 3 broad areas of studies. These are biological sciences, chemical sciences, and physical sciences. Biological sciences deal with the study of living matter, whereas chemical sciences and physical sciences deal with the study of non-living matter. It doesn't end here. These disciplines can be integrated into 2 further broad areas of studies. One that deals with the medical sciences and the second one that deals with engineering and technology. Medical sciences is basically integration of the biological and chemical sciences, which blends the study of the living matter and the behavior of the non-living matter, which is similar to the way living matter behaves. And the second discipline, engineering and technology, is basically an integration of the chemical sciences and physical sciences, both of them involved with the study of non-living matter. But the difference is that the chemical sciences impart us education on the way a non-living matter behaves, what it is composed of, whereas physical sciences basically involved in measurement, the forces, and basically an application part of it, that how a matter can be put to work. The two broad application-oriented areas of science education that I just mentioned, medical sciences and engineering and technology, can be further divided into different areas of study, or we may call them as sub-disciplines. Like in medical sciences, we have microbiology, biochemistry, pharmaceutical sciences, radiology, physical education, home sciences, dental sciences, clinical sciences, and so on. Similarly, in engineering and technology, we have different sub-disciplines like earth sciences, agriculture, chemical processing, mathematics, machine learning, electronics, computer sciences, industrial production, flow mechanics, and so on. To conclude, science education is a complex array of different areas of studies or specializations which have their foundation or roots that lead to the basic sciences, which are chemical sciences, physical sciences, and biological sciences. Secondly, science education is based on scientific philosophy, scientific theories, and established scientific resources. Lecture 2: Scientific Skills. Let us begin by understanding the meaning of the word skill. The term skill means personal ability, talent, or capacity of an individual to perform. Skill can be viewed as the ability of a person to carry out a task in order to bring out the desired results. The result is an outcome of a duty, which should be free from errors, correct, accurate, and precise. The precision of the outcome depends upon the skill of the individual or his or her capacity to perform. Scientific skills in this regard can be viewed as working skills or knowledge skills possessed by an individual. Scientific skills empowers a person to carry out a given task. Scientific skills are closely related to one's understanding, reasoning ability, and creative abilities. Scientific skills helps to frame the cognitive abilities of a person to carry out a routine task on daily basis. Now, in order to understand what a cognitive ability is, a diagram has been illustrated. The cognitive ability is a combination of one's knowledge, experience, memory, and judgment. The ability of a person to perceive information is framed by the knowledge possessed by an individual. Second, the ability of a person to associate a logic or associate information presented in the subject is framed by the memory and experience of the individual. Third is the ability of a person to make some decisions and to be able to give some reasons on the basis of which the decision has been made. Now, this depends upon the scientific principles of observation and analysis. A person should be able to judge and draw some conclusions. Fourth is the ability of a person to communicate ideas with others. Given a combination of these four skills leads to overall development of cognitive abilities of the person. Let us try to look at scientific skills from a different point of view. Let us try to classify scientific skills on the basis of scientific philosophy and working principles. Scientific skills can be classified into four major categories. First, education. Second, observatory skills. Third, experimental skills. And fourth, analytical skills. Education and observation can be said as theoretical skills possessed by an individual, while experimental skills and analytical skills are more practical and working skills. Education skills, in general sense, depends upon the academic knowledge possessed by an individual, numerical abilities, writing abilities, ability of a person to think critically and present information. On the other hand, observation skills of an individual depends upon radical thinking, ability of an individual to compare and contrast information, ability to conduct surveys, examine, and to be able to draw some conclusions. A more practical approach to development of scientific skills are the experimental and analytical skills possessed by an individual. Experimental skills impart the real working tools. It depends upon the ability of a person to utilize materials, resources, tools, and technology available at hand. It also depends upon the ability of a person to research and develop creative abilities. Safety in working is also one of the key features. Finally, analytical ability is a process of interpretation, imagination, reasoning, and judgment. It leads to livelihood creation. Now, let us look at some of the ways that can enhance scientific skills of an individual. Improvement in scientific skills can be brought about by improving language skills, enhancing scientific vocabulary, building capacity to perform numerical operations, scientific research, conduct experiments, building technical and tooling skills, improving working strategy, exploring different ideas and concepts, and finally, improving communication skills. Okay, let us recap what we have learned so far. Scientific study can be divided into many subdisciplines of science and technology. Science education can help us answer complex questions about origin, existence, occurrence, and behavior of living and non-living matter. Scientific facts are built on experimental results. Research helps us to explore different ideas and concepts, which forms the basis of scientific theory, discovery, and invention. Scientific skills are governed by scientific principles of hypothesis, observation, experimentation, and analysis. Scientific skills are a complex array of skills that frame knowledge and cognitive abilities of a person. Lecture 3: Scientific Communication. Communication is a process of giving information to another. It means transfer or sharing of knowledge, thoughts, and ideas. The two modes of communication are verbal communication and non-verbal communication. Verbal communication is an act of conveying message in the form of written expression or oral speech. It is a formal mode of communication. Non-verbal communication is an act of conveying message through informal route, which involves hand movement, eye movement, or personal body gestures. To understand the communication process, a diagram has been illustrated. Simple communication has three basic entities. These are sender, receiver, and a channel. Sender is the first person in the communication process. It is a person that encodes a message. Receiver is the second person in the communication process. It is a person that decodes the message sent by the first person. Channel is the medium of communication that bridges the gap between the sender and the receiver. A communication channel may be a print medium like a book, newspaper, or a magazine, or an electronic medium like a television, radio, internet website, or a computer game. A good professional is judged by his ability to present ideas clearly and the ease with which his ideas can be comprehended by others. In this regard, the communication process can be viewed as delivery of message from sender to the receiver coupled to a channel for transmission of the message. Elements of scientific communication. The three basic elements of scientific communication are research and development communication, technology communication, and industrial communication. These three basic elements of scientific communication helps to build information resources, to develop cognitive abilities, and to make scientific progress by an individual, community, or nation at large. Communication is one of the essential components of science education. One of the key ability of the scientist is to engage in innovative thoughts and formulate an ideal approach for solving difficult problems. Research and development helps exactly to achieve this objective. The communicator must perform a subjective and objective analysis of scientific theories, matter, and scientific principles. The second element, technology communication, refers to availability of technical resources at hand. These could be in the form of materials, techniques, machineries, and equipments. It also refers to technical know-how to carry out scientific experiments and conducting trials in various subdisciplines of science. The third element, industrial communication, also refers to business communication in science. It deals with various entities involved in the communication process. These could be scientific communities, academic communities, education societies, industrial communities, business professionals, and general public. The extent of communication within and outside these entities depends on various needs of the individual. Now, let us understand the scientific communication process. Given the three basic elements of scientific communication, the scientific communication process can be viewed in form of a pyramid. The base of the pyramid represents the first element, and the apex or the top of the pyramid represents the final element of the scientific communication. The scientific communication process can be broken down into several different steps. Starting from bottom to top, these are scientific evaluation, data mining, experimentation, trials, presentation, and application. Let us understand these steps in brief. Scientific evaluation means selecting the right information resource for subjective and objective analysis. Data mining means selecting the right content from the information resource, choosing the applied content, the context which is relevant for communication. Experimentation means verification of theory and testing of hypothesis. Experiments can be modified into field trials. Modification of experiments means detailed observation, analysis, and carrying out further experimentation. Once a scientist is satisfied with the results of his experiment and the outcomes of his experiment, he then chooses to present his findings in form of a structured data. Good presentation of the data and target selection of the entity are the final steps in the scientific communication process. Scientific communication techniques. The techniques of scientific communication refer to established norms, conventions, or rules for formal communication. It is recommended to use the prescribed norms by International Standard Organization for formal communication. The first and foremost is the scientific vocabulary. Scientific vocabulary refers to use of established signs, symbols, words, definitions relevant to the field of study. Second is the scientific syntax. It means established laws, principles, theories, rules, and notations of historical importance which are presented in the scientific literature. Third is the representation of the scientific data. The technique involved in communication is use of diagrams, tables, graphs, pictograms, sets, maps, and so on to represent the data. The large amount of scientific data can be condensed into a single drawing or a map, which is easy to understand, analyze, comprehend, and draw important inferences. Fourth, scientific writing techniques. It is a standard prescribed format for writing a scientific document, which could be an abstract, a dossier, a monogram, or a scientific experiment. Fifth, scientific review. Now, these are another set of scientific writings that give information on techniques pertaining to use, application, hazard, or safety of an equipment or a product. These scientific writings are in the form of labels, prospectus, catalogs, and safety manuals used by various agencies. Sixth is the scientific evidence. Now, it is a technique that serves the purpose of a material evidence. Material evidence may pertain to evidence of a substance, a tool, a technique, a process, a computer application, a machine, or any industrial equipment. Finally, we have standardization of protocols or technical modus of operandi. It is a technique that deals with standardization of technical operations during installation, inspection, commissioning, and regular maintenance of any plant equipment or a machinery. To conclude, the basic elements of scientific communication can be broken down into various steps, and scientific communication must be in accordance with the prescribed norms and techniques. Lecture 4: Science, Industry and Business. Industry is a generic term that explains business and commerce. In science, industry is an application-oriented approach for development of tools, technology, products, and services. A difficult task can be made simple with the help of technology. So, technology, products, services helps to improve the living conditions of people on daily basis. Industry can be viewed as a complex web of what we have studied in the previous lectures, which is science education, scientific skills, and elements of scientific communication. However, in practice, it means exchange of information or several types of trade practices among various bodies that are involved in the development of industry. Now, let us understand this aspect further. Given any industrial domain, there are three prime areas of concern. First, production. Second, consumption. And third, business support. Production is a mechanism by which technology, products, and services are created. The creator is the producer. That can be categorized as technical professionals such as manufacturers, contractors, engineers, and research scientists. Consumption is a mechanism of using products and services. The consumer or buyer can be categorized as a technical professional or general public. The third area of major concern is the business support. This refers to integrated support received from other industries. For example, let us consider our industrial domain as the healthcare industry. The producer is the doctor and other medical staff. The consumer is the patient, which refers to general public. So, business support is the support received from other industries like agriculture, leather, textiles, paper, pharmaceutical, insurance, defense, real estate industries that are useful for healthcare industry to carry out its operations. Business management techniques. Managing business is not an easy task without proper knowledge, skills, and technology. However, an important technique in business management is the maintenance of technical records. Technical documents refers to a set of common documents and dossiers which are important for business operations. This varies from business to business. Some of the important documents are laboratory data, testing data, research data, batch records, quality reports, service reports, regulatory certificates, and other legal documents. While these documents would help you to manage business operations effectively in the long run, an important strategy for business management is to enhance knowledge, upgrade skills, maintain technical records, perform regular quality checks, and improve the business economy. Conclusion: industrial professionals can make use of scientific techniques and technology for business communication. Industry professionals should adopt scientific procedures for quality control and business management. About the lecturer, Mandeep Singh completed his graduation in Bachelor's in Engineering in Chemical Engineering in the year 2006. He did his post-graduation in Masters in Sciences in Biochemical Engineering in the year 2008. He is the proprietor of VMG Academy and has tutoring experience over past 7 years.